Cool, so I've managed to do number 1 and 2 for you from exercise 1. I'm on number 3. Here we go. Let's just get my pen set up. Okay, number 3 says evaluate without using a calculator. So sit on your calculator. You're not going to use it at all. Cos 290 and sine 80 plus sine 430 sine 10. Okay, so clearly we're going to have to use our compound angles at some stage, but we're not quite ready to do that just yet. So we first got to do some legwork to get there. So firstly, this guy here is going to need to change a little bit. So what? 290 is in whose quadrant? Remember, we're dealing with this quadrant over here, the CAST. So we are in the 4th quadrant over there. Okay, so that's going to be the same as cos of 360 minus what? 70. Right? Sine 80, it doesn't look to have any issues with just yet. So I'd suggest you just leave that guy for now. Plus sine 430, we don't need to go 430. That's the same as saying 360 plus 70. You don't have to do that bit of working, but I'm going slowly. And sine 10, you see that sine 10 hopefully should match up with that sine 80. Okay, so we're going to have to somehow change the second one maybe into a sine of 90 minus what? 80. Right? So now we're going to use our reduction formula, or maybe co-ratios to simplify life a little bit. Cos 360 minus 70, you're going into cos's quadrant, so that reduces to a cos 70. Sine 80, we haven't changed. Sine 360 plus 70, you're going into the first quadrant again, so that everything's positive there, so that's sine 70. And then this guy over here, you remember that's a co-ratio, so going from sine 90 minus will become cos of that thing there, 80. Cool? So that's some good marks over there for you. Now, what type of ratio are we in? Okay, you first have to decide that for yourself. So this starts with a cos, then a sine, and a cos. So because they rotate each other, and it's not cos, sine, it's going to be a sine rule. So if you want to, you don't have to. You could choose to write it like so, right, just to really show yourself that it's in the format of the sine rule. So it's going to be sine of what? The plus sign carries through, right, because of the sine compound angle. And we're going to have that, which is the same as sine 150. But don't stop there. You remember you're asked to evaluate it. You need an answer for this. So sine 150 is the same as sine 180 minus 30. Remember, reduction formula. So using our cast diagram, we're going into sine's quadrant, which makes it positive there. So that reduces to sine 30, which we should know by now is a half. Remember your special triangles, you've got to have 45, 45. Let me just write this again once more. And eventually you can do this so quickly because you are practicing loads. There we go. So 3, done. Number 4, prove that. Okay, so we're going to be given an identity now. You have to prove that the left-hand side equals the right-hand side. You know these by now. So the left-hand side is equal to, and you could often go like so and actually write for yourself left-hand side equals. You don't have to, but it makes it look pretty, I guess. Okay, so here's your question, and you firstly just going to expand it. So your left-hand side, when you expand it, is sine A cos 60. And then what? You're going to have a minus or a plus. You're going to have a minus, and you're going to have cos A sine 60. So that's that expansion done. I must write small now. And then cos A cos 30, and then plus sine A and sine 30. Okay, cool. So I've expanded everything like so. I'm going to be using special triangles now. Sine A, can't do much there. Cos 60 is going to be a half. Just check my triangles over there. See if you agree. And then minus cos A, can't do nothing. Sine 60 over here is root 3 over 2. Hope you agree. Plus cos A, can't do nothing. Cos 30 here is root 3 over 2. And then plus sine A is just sine A. And sine 30 is a half. Cool. So as far as we can now, we're going to simplify stuff. Do you notice that that over there and that over there are like terms? The ones are negative, the ones are positive. So they're going to be cancelled out. What have I got over here? I've got a half sine A, and I've got another a half sine A. So together I'm going to have 1 sine A. Obviously you don't have to write the 1, which now we can write the beautiful thing equals RHS. Okay, Good stuff. Now, 5.1, more identities. Let me go up to make some, okay, I'll let this one. 5.1, I'm going to try to do 5.1 is not the nice one, so I'm going to go 5.1. I might not do all of them for you, just to save time and data. Okay, so there is 5.1. Let me just write it out. Root 2 sine of x plus 45 plus cos of x plus 90. Okay, and hopefully we're going to be equaling cos x. Let me just write it over there for now. Okay, so that's our goal. So when we talk about the sine rule, the root 2 is not involved. So now we're going to have sine x cos 45 plus cos x sine 45. And that's one is done. And you're going to have plus cos x cos 90. And then minus sine x sine 90. Okay, cool. So now we're reading from left to right again. What could we do now? This is the issue. This is where it can get a bit confusing. Is we are going to do the following. We're going to take out a root sign, and I know it, or root 2, and I know it's not common everywhere. Like if you look on this, okay, let's think about this before I dive in. Okay, first of all, what is cos 90? Oh, my calculator. If you just double check for yourself, cos 90 is equal to nothing, is equal to 0. So if that is equal to 0, obviously this whole thing there is falling away. Sine 90, just to remind yourselves, sine 90 is equal to 1. So if that's equal to 1, the only thing remaining is minus sine x. Okay, so now we look again at this term over here, one big term. I'm going to take out a root 2. Okay, what is left? I've got sine x left. Now what is cos 45? Remember, cos 45 here is 1 over root 2. Okay, that is what cos 45 actually is. So now if I've taken out a root 2, okay, I'm going to have 1 over root 2 over there. Is that right? Let me just remind myself here. What is cos 45? Heckle and hackle. There we go. 1 over root 2, 2 over 2. Yeah, these can get quite tricky, hey? Let me just remind myself here. Okay, I'm not taking out an HCF, man. Okay, I've messed up here a little bit. Just to backtrack a little bit so I don't have to push stop on my recording. Putting brackets in here, so that root 2 is applying to everything that the sine compound angle rule has expanded to. Okay, so it's not an HCF. I've just left it out on the outside over there, and now I've changed my cos 45 into that. Sorry about that. Cos x can't do anything with cos x. Sine 45 is 1 over root 2. Okay, plus, as I said there just now, that became 0 over there, and all that was left there, I'm not even going to put a plus, is a minus sine x. Okay, so now when I times my root 2 in, if I times it in there, all that's going to be left is a sine x, because the roots have cancelled each other out. And when I times it in over there, I'm going to have, what am I going to have? I'm going to have a cos x, eh? The roots have cancelled out each other again, and I've got the minus sine x chilling at the end. And then sine x and the minus sine x gone, and I've got cos x, which, look at that, is equal to the right-hand side. Lekker. I'm going to stop this video.